Okay.
Hello, we are group 12. The first selected paper has the title, A Scalable Approach for Fraud Detection in Online E-commerce Transactions with Big Data Analytics. Our topic is Big Data Analytics. Online e-commerce transactions for fraud detection. The convenience and availability of online e-commerce paying methods have changed our lives at a global scale, but have also opened the door to a myriad of new fraud possibilities. The quantity and diversity of data handled by the online e-commerce applications is huge, namely financial transaction records, personal information, behavior habits, locations, etc. This is for sure a big data problem and also an adversarial problem, where fraudsters put all their creativity to find new ways to deceive others. All these raise the performance requirements both in accuracy and real-time responsiveness. This work proposes a novel, scalable and comprehensive big data solution for fraud detection in online e-commerce transactions. And this work can be divided in three parts: infrastructure, framework, and experiments. Infrastructure. The infrastructure is built using Apache Spark on Yarn, and it uses Hadoop distributed file systems to distribute and store the dataset on the data nodes. Yarn Resource Manager distributes the computations tasks to the Spark worker nodes. The proposed infrastructure aims to provide big data analytics effectively and efficiently, accomplishing in this way the real-time requirements. It has two main features. It is easily scaled out, adding more nodes to the cluster, and implements computations and the machine learning algorithms in a distributed way. The framework. Each transaction is evaluated going through a pipeline that is divided into 4 logical modules: transaction data preprocessing module, rule-based expert system module, machine learning fraud detection module, deviant behavior discovery module. The transaction data processing module is responsible mainly for cleaning, filtering, consolidation, and transformation of the dataset. The rule-based expert system module consists of an expert system based on a rule set defined by experts on fraud and a semantic reasoner. The machine learning fraud detection module implements 3 machine learning algorithms: convolution neural networks, decision tree, and support vector machine, ensembled with a simple voting strategy. In the deviant behavior discovery module, the objective is to detect novel forms of fraud behavior. For that purpose, this module implements on Spark a distributed k-means clustering algorithm. The experiments. The experiments are made on premises on a cluster of 12 machines, each with 8 cores and 32 gigabytes of RAM. The dataset contains over 6 million records of online transactions from a Chinese e-commerce company. To cope with the imbalanced dataset, 5 balanced datasets of train and test data were produced. For each of those experiments, a comparison is made between the proposed approach and traditional CNN, decision trees, and SV models. The selected metrics for comparison in this work are recall, precision, accuracy, and F1 score. Broadly, in all metrics and across all experiments, the proposed approach is on average above 90%. F1 score comparison is selected and presented here because it is the harmonic mean of precision recall. The plot shows that F1 score for the proposed approach is around 90%, the next best CNN is around 70%. As final remarks, I should add that the proposed approach, according to the authors, accomplished the runtime requirements necessary in the context of online e-commerce transactions because of its distributed nature and parallel computations on Spark and HDFS technologies. It is also easily scalable. The framework, with its 4 logic modules, provides the major components of a fraud detection system. In this sense, the system is comprehensive and as a whole provides efficiency and effectiveness. About the evaluation experiments, I should add that the performance comparison between the proposed approach, that is an ensemble of CNN, DT, and SVM, and a single traditional model per se seems not very impressive in 2019, since in most of the situations the performance improvement of an ensemble is a known fact with tons of practical work supporting it. In the discussion about the metrics, it misses a relevant aspect of this context, that is the false positive rate. The false positive rate has a huge impact on the selection of fraud systems because it puts a lot of pressure on the relationship between consumer and provider. No one likes to see its legitimate acquisition delayed or rejected by an algorithm. A relevant aspect is the proposed future work of implementing the proposed approach in the industrial big data environments, such as cloud computing environment in a data center. It is a crucial step to the validation and business adoption of such a system. And this finishes my presentation.
Okay, thank you, Antonio. Here is Otávio. I'm going to present my part now. Please, can you stop share screen? I'm going to share mine.
Okay.
Okay, thank you. Yes, it's here. This one. Start sharing. And mine begins here. Why it's not showing? Can you see mine?
Yes.
Can you see my screen?
Yes, I can.
With the slide, the first one?
Yes, the first one.
Okay,
Correct.
thanks. Hello, Kalia. Hope find you well. My paper title is a Spark-based big data analytics analysis framework for real-time sentiment prediction on streaming data. So here I have an introduction. It's a Turkish paper. So he was researching around sentiment analysis, and he concluded that today, as data is being produced in very large volumes, and the speed just increases with sensors, as car sensor, in digital media you have images, videos, etc. In machine log data you have geolocation. In archives and documents such as HTML, XML, mail, you have a huge amount of data being generated over time. So new distributed processing solutions are required to extract that valuable information. So in big data analytics, you have tools such as Spark, very powerful and very fast. One of the most demanding research areas in big data and Spark, as the author was saying, it's sentiment analysis. And what I think is very important here is the quality of the data, also the major as the major impacted points regarding the authenticity of the owner that generated that sentiment. So both fake account detection and system and sentiment analysis were trained with NB, naive Bayes model with the Apache Sparks machine learning library, MLlib package for Turkish tweets. He applied that for Twitter. So he's doing two things here. So the sentiment analysis and the fake account detection to avoid those kind of data that will, in certain things, build a bad data for him. As frameworks and ML algorithms, we have two options here. To widely used distributed data processing approach, which is Hadoop, depending on the MapReduce model, and Spark, relying on the RDD, Resilient Distributed Dataset. The main difference is that the latter uses an in-memory model, resulting in a much faster data processing. Spark, while the former, the Hadoop, uses a disk-based processing approach. With the use of Spark streaming, machine learning algorithms can be used in two cases. With the MLlib, the library, which is created offline, and then train model is used for analysis of streaming data. And second, training MLlib algorithms at runtime to evaluate stream data. Here I have the outline of the proposed system. So we have 4 steps here. The first one, it's that DB that you see here, the dataset UMIR. It's a Turkish one, well known over there for hotels and restaurants review. He used that separated for train the model. So once trained and pre-processed, he gets vectorized and then applied to the model. On the second cluster here, you have Twitter streaming service, which is it's online and on the fly, as he says, which you have the processing here of the texts. He filtered the tweets, put that in a queue with rabbit in a queue. On the third step, it's the Twitter fake account detection with machine learning system, where he can determine which is fake or real. If it's fake, he remove. If it's real, he move forward to the last one, the 4 steps with the real-time reporting and dashboard software. Well, on implementation and conclusion, as I said, he used the UMIR dataset. He created 2 different versions to evaluate the proposed sentiment prediction framework. The first one is the original one, the org with no preprocessing, and the second one is the preprocessing, including punctuation, cleaning, tokenization, stop word removal, and steaming steps. So basically 80% of the data was used to train the NB model, learning model, and the remaining, the 20% for the tests. In the first run, the accuracy and the F measure values were obtained 85% and 85.21 and 85.12 for the original one. In the second run, with the processed, the values were improved in about 2%. Okay, on implementation, here it's important to say as well that he used Django, as the framework to do it. Sorry, I have some notes here. The Spark Python API, PySpark, that supports Spark's programming model for Python was utilized. Django Web Framework was used for rapid development of secure and maintainable web application. The whole system was hosted on an Ubuntu running Apache web server using WSGI. Metadata information parameters. It's on that slide here. So metadata information, parameters, keywords, account information, and sentiments of retrieved tweets were stored in MySQL database. And a messaging system was constructed using RabbitMQ, as I said, and used with the Pika Python client. Another thing here, and lastly, on the conclusion, to compare the training time and accuracy of naive Bayes, they have also tested logistic regression and SVM using the same Spark cluster configurations. SVM has been training 354 seconds with 87% of accuracy using the one master and 4 worker Spark nodes. Logistic regression algorithm, on the other hand, has been trained in 120 seconds with 80% of the accuracy, and SVM with a better accuracy has been fewer with 267 seconds, but nothing compared with naive Bayes with 87 seconds. That's the reason why he selected naive Bayes as evaluated algorithms. And for future work, the sentiment analysis, it's mainly a classification problem regarding the outer problem that can be solved with the use of machine learning algorithms. There are numerous methods that are used to extract emotions from microblog texts like Twitter. And he says as well that this work may be adapted to any field with slight modifications. So with more clear terms, the sentiment prediction service may be trained for a new application such as recommendation or brand tracking, and it may be used to extract sentiment for those fields in real time. And that's it. Thanks. Sorry for my poor English. And that's it. You have something to add here, Antonio?
No, that's all, I think. Thank you very much for your time.
Okay. Thank you.